Okay. I'm just going to stop sharing the screen for a second while I just check up on, make sure the sound's working. I hope it is. Yeah, there's little buttons going up and down, so that's all right. I'll go back to sharing the screen if I can. And good, right. Hi. Good morning. My apologies for last week, but I wasn't worth anything last week. I was very sick and not too good this week either. But we'll see how we go, and hopefully I'll last the week just as well. It's a public holiday on Friday, so that I can have a bit of a break there. Now I'm going to start off this won't go for very long. I'm just going to rehash some of the things that are in the lecture this week. Very briefly, just draw out a few more points, and then I'll look at the class activity. And after that, I will close up. It'll be the finish of it. So a couple of things. Because I've been sick, I think I sent an email about this anyway. I'm way behind in my marking. So I expect I won't finish all the marking before the end of week 13. So I have to ask you to be patient. Sorry about that. I have started marking I've marked the first few, I think about 4 assignments. They take quite a while to do, so I'll do them first. I'll eventually work through to everybody having had their mark. What I'm doing is I have the rubric mark sheet or spreadsheet I'll put in your group assignment folder when I've marked your work. You'll see, as I write comments anyway, that I'm working on your work. And when the marking's finished, you'll see a spreadsheet. It should say your group name and assessment. And that'll be your mark. Eventually it'll end. It also should appear in Blackboard as I move through. But it will take a while, so my apologies for that. I do have to be very careful not to get sick again. I did have so it wasn't just a cold or flu, I also had pneumonia, which is the main problem at the moment. I get out of breath pretty quickly. And my doctor says that'll take about a month before I'm really better from that. So I'll just have to take it easy. So I'm not promising anything to be completed before the end of week 13. Sorry about that. Also about week 13, I'll run up catch-up classes on the Monday of week 13. So if you'd like to come in at the normal class times, that's at 10:30, 1:30, 3:30, I'll have the lab open and I'll sort of be in and out to provide any help that's needed. So if you're running behind time, don't panic too much. There's no new work in week 12 and there's then the week 13. So unless you've been completely far behind and haven't been doing any work, in which case I won't be marking you anyway, but I'll be anything from week 8 onwards, it'll be fine. As long as you've got it done in week 13, you'll get all the marks. We also had a bit of a heroic effort on Monday with some of the lab tasks, which didn't work properly. So those who are there know why. Hopefully, for today's class, it should go fine. I spent some of yesterday while I was at home being sick, double checking, making sure it was all working. So hopefully today it'll just fly through. Okay, so that's the preliminaries. Let's have a little look at the topic, which I assume you've all read, so all the details you should know about. I just want to put a bit of context into it. And as you see here, they're the three major topics, which was visualization and the cloud. You might like to come and look on here rather than me putting it up on the screen, because there's a long lag with the you can come up and just stand. Well, it's slow. I'll be talking and you won't be seeing it, a long time later. So just come around here. No, you need to look at this screen here. No, you need to look at this screen here, because this is the one with the actual up-to-date one. Okay, so they're the four main points: virtualization, the cloud, Internet of Things, and data analytics. So the theme is big data. So I'll start off with virtualization, because that's really the enabling technology for big data. Big data really would be much harder to do if we didn't have data centers with virtualization. So I'm just going to assume you know what virtualization is from having read the notes and from having used it in your labs using virtual machines. The big thing that virtualization does is to provide on-demand computing power. So when somebody has a big job that implies lots of data crunching, they don't have to have their own data center with lots of computers that are only going to be used, when there's a big analysis going on. They can hire it from Amazon or Google, mostly Amazon. You can do it from Microsoft as well. Microsoft, Google, probably the biggest ones in this space, and the big one is Amazon. Amazon makes its money from being able to run up a computer instantly. So if somebody has a big, huge batch of data to process, they can get onto Amazon, they can fire up a couple of hundred computers, do their analysis, upload the data, crunch the data, download the results, and then close down the computers. They only pay for it for the time that they're actually using it. Now, if you're using lots of computers and lots of computing power, it's going to cost you. It's going, Amazon, of course, is making money out of this. So there'll be, even though, you can bring up a small computer and run it for cents a day, if you're running a big job, it's going to cost you a significant amount of money, but not as much as running your own data center with all these machines that might only get used for 10 hours a month. So that's the big deal with big data, and that's what makes big data feasible for most companies. Obviously, if you're Amazon or Facebook or Pinterest or Instagram or any one of those companies that makes its money out of, or Google, of course, out of targeted advertising, then you're going to be doing this big data crunching all the time. So you have your own machines. So big data, there's companies that make their money out of big data, and the way they do that is by looking at what you're doing and basically spying on you. But hang on, you are using their service for free, aren't you? So you're part of the product. You're not really the customer, you're the product. And they present you with advertising that's targeted to you. Hopefully you'll buy more stuff that way. And so the service providers like Amazon's customers, for example, are and Google's customers are paying more for the advertising that's targeted than if it was just like TV, which is sent to everybody. So that's where the money is in big data. And of course, other companies like big retailers and that sort of thing, they're probably not doing it all the time, so it's cheaper to use Amazon to do the data crunching. Okay, so Now, the next thing is the cloud. Now, you should know these initials: software as a service, platform as a service, infrastructure as a service. I'm not going to explain those because you should know what they are from the notes. But the big hitter for cloud, for data crunching, for big data, is infrastructure as a service, where you can bring up a whole computer virtually. You bring up hundreds of computers virtually, do what you like with them, run your own programs, whatever, and then close them down. And that's infrastructure as a service. That's software as a service and platform as a service are not really big data services. They're mainly for running applications. So that's the big thing there, the cloud and infrastructure as a service. Okay, now data analytics. As you should know by now, it's a way of getting meaning out of data, and huge data sets, gigabytes and petabytes of data, terabytes, petabytes probably. If you're wondering what a petabyte is, it's 1,000 terabytes. It's a lot of data, and that data has no meaning until it's analysed. And if you're going to analyse it, it takes a lot of computing power. And so that's the big thing at the moment, data crunching. The companies that can make meaning out of their data are the ones that make lots of money. Even companies that say do manufacturing and what have you, particularly the big ones, they're into this too. Miners are into it. You wouldn't think that miners are into big data, but they are. Perhaps not as big a data as some of the other ones, but they're all looking at big data to find out how they're performing. It's just a little example, which I sometimes quote about. Goes back a while now. There used to be a company in Australia, airline company called Ansett, which is now dead, gone and buried. Went broke, but at one stage, and this is in the early days of big data, they wanted to find out what was their most profitable routes, and everybody assumed it was Sydney, Melbourne. It's one of the busiest air routes in the world, believe it or not, Sydney, Melbourne, and they assumed that that's where, per trip, that's where the money was. It actually turned out to be Perth to Port Hedland. Like, in terms of actual flight, not totally, of course. Sydney, Melbourne was making the most money overall, obviously, as you'd expect. But per trip, I think it was Perth to Port Hedland or Perth to Mount Newman, one of those. Very unexpected. So that's some of the things that big data, can show up surprises. I guess most of what you see in big data says, yes, pretty much what I expected, but sometimes there are surprises. So getting meaning from big data is what data analytics is all about. And I chucked in the Internet of Things there. Internet of Things is really, in spite of all the hype, is really in its early days. I mean, lots of people get excited about making their front door open automatically or turn their air conditioning on automatically. I look at that and think, you know what? Turning a knob on the door is just as easy as using a phone. So to me, I'm not into home automation. I think, it's for people who have nothing better to do with their lives. But that's only me. Internet of Things is going to be big and is growing. Internet of Things, if somebody came up with, I don't think it's gone anywhere, but the idea of actually having paint with a whole lot of sensors in it. So the paint had little chips into it. So you can actually paint a wall and use it for sensors. There are actually sensors everywhere, and even if you think about closed-circuit television. I mean, that's not often thought about being as in the Internet of Things. But at the moment, you've got guys sitting there looking at the screens for all these closed-circuit television. Now, we know that I think people have got about 15 minutes of attention before they start missing things on the screens. Because they're just that you can't hold your attention on a whole lot of screens for more than about 15 minutes. Now, this is the golden egg. If you could get artificial intelligence to actually look at those screens and look for things that are unusual, then that'd be great. And it's more than that. Sensors in buildings, trying to maximise energy use. There's quite a bit of that in RMIT. You might have noticed. Pretty crude by today, by standards of tomorrow. Like the room I'm in now, the lights came in when I walked in the door. I didn't turn the lights on; they just turned themselves on. The air conditioning gets turned on when somebody comes in the room. There's nobody in the room; it all turns off. That's saving money. So these big data is going to go into areas that we really haven't thought about. Now, if you just think about self-driving cars, the amount of data that's required to get a car, especially if you go to what's called level 5, where the car runs itself in any situation. Level 4 is when it'll run on a freeway. Level 5 is when it can run anywhere. Just think of the amount of processing that's involved in that. And that data can be transmitted back to the headquarters so they can see how their cars are performing. In fact, in some brands of cars, that happens now. If you have a Mercedes, some of the more expensive Mercedes cars, it's talking to home all the time. Mercedes can tell where you are, what your car's doing, all the time. So it's sort of here now, but if self-driving cars actually, if they can make them work, huge amounts of data. And also the cars will talk between themselves. So if you're going along a highway, your car won't have to only use its radar to see if the car in front's stopping. The car in front, if it's about to stop, will tell your car that I'm about to stop. So, and you'll have street signs that talk to your car. So no traffic lights, because you won't need the lights, because there'll be some transmitter that say, stop, it's not your turn. So the cars will stop without the lights. All this sort of thing. Huge amounts of data being stored. So the Internet of Things is going to be just a huge source of big data. Okay, so that's just to run through the lecture, with just giving a bit more of a twist than what I've got in the notes. But the class activity is pretty simple today. And you can divide this easily amongst your group, so that you can share it out probably without too much coordination between you. But, don't make it look as if it's all different. But so each of you take an example of a company. Just make sure you don't have the two people in the same group don't have the same company. That's all. Find companies that are using big data and find out what they're doing. Don't only go for the Googles and the Amazons, because we've talked about them. Try and find something else. Some other company other than the big hitters, the Googles and the Facebooks and all the social media ones. See if you can find something else. I mean, obviously, if you get desperate, go back to Instagram, but if you can, try and find something that's not been mentioned so far. All right, so that's about it for today. I'll stop talking, and I'll see you next week sometime.